Welcome back to the Science Hub SKB. Part 4. Homogeneous mixtures, heterogeneous mixtures, and separation techniques. What is a mixture? A mixture is a combination of two or more substances that are not chemically combined. This simply means that a new substance is not formed in the mixing process. Mixtures consist of a solute and a solvent, where the solute is in the lesser amount and the solvent is in the greater amount. There are two types of mixtures. You have homogeneous and heterogeneous mixtures. A homogeneous mixture appears to be one substance, for example, sugar water, crude oil, alloys, and natural gas. A homogeneous mixture is one in which the solute dissolves completely within the solvent. Examples of homogeneous mixtures include wine, juice, soda, brass, vinegar, blood, coffee, and air. A heterogeneous mixture shows the separate parts quite easily. For example, sand and water, rice and peas, soil, rocks, and dirt. The heterogeneous mixture is one in which the solute does not dissolve within the solvent. All components of the mixture can be distinguished. Examples of heterogeneous mixtures include hamburger, oil and water, pizza, ice in soda, sand and fish in water, chocolate chip cookies, and vegetable salad. Mixtures can be further categorized as either being a solution, a colloid, or suspension. A solution is a homogeneous mixture. Its key features include uniformity at the molecular level where there is no settling. Examples of solutions include salt water and air. A colloid is often a homogeneous mixture but quite borderline. It appears uniform and the particles don't settle but they do scatter light. Examples of colloids would be milk and fog. A suspension is a heterogeneous mixture. Its particles are visible and they settle over time. Examples of suspensions include muddy water and sand in the water. In everyday terms, think of solutions and colloids as well mixed, mostly homogeneous, while suspensions are visibly uneven, so they will be heterogeneous. Mixtures often contain components that need to be isolated or purified for various practical, scientific, or industrial purposes. Separation techniques are essential because mixtures are common in nature and industry, and we often need to isolate or purify substances to make them useful, safe, or recyclable. Separating mixtures is important to obtain pure substances, to reuse or recycle components, to analyze substances, to remove harmful substances, to improve efficiency in manufacturing, to separate components with different uses, and for environmental reasons. The choice of separation technique depends on the properties of the components in the mixture and how they differ from each other. Key factors that determine which method of separation technique is suitable for separating components out of mixtures are state of matter, particle size, solubility, density, boiling and melting points, magnetic properties, affinity for a phase, and volatility. Let us explore 6 types of separation techniques. We have filtration, paper chromatography, evaporation, decantation, simple distillation, and fractional distillation. Filtration is based on particle size. It separates substances in a mixture by allowing smaller particles like liquids or gases to pass through a porous material called a filter, while larger particles like solids are trapped. Paper chromatography is based on the difference in solubility and affinity of substances in a mixture for 2 phases. 1. The stationary phase, the paper which absorbs substances, and 2. The mobile phase, a liquid solvent which carries substances up the paper. Evaporation is based on the difference in boiling points of substances. It separates a liquid from a dissolved solid by heating the mixture. The liquid with a low boiling point evaporates and turns into vapor, while the solid with a higher boiling point remains behind. Decantation is based on the difference in density between substances. It separates a liquid from a heavier solid or 2 immiscible liquids. The denser substance settles at the bottom. The lighter substance is carefully poured off or decanted. Simple distillation is based on the difference in boiling points between the components of a mixture, where the boiling points are widely apart. While fractional distillation is based on the difference in boiling points of multiple liquids, where the boiling points are very close together. A fractionating column is used for better separation. This is your fractionating column. So, let's look at separation techniques in a tabulated format. Filtration is based on particle size. An example of a mixture that is filtrated would be sand from water. Decantation is based on density. An example of a mixture used would be oil from water. Distillation uses boiling point. An example of that would be alcohol from water. Chromatography uses affinity for a phase, and we have, for an example of that, ink components. Evaporation uses volatility, and an example of that would be salt from seawater. Centrifugation uses density. An example of a mixture using centrifugation would be blood components. And then lastly, we have magnetic separation, which uses magnetic properties. An example of a mixture that uses magnetic properties would be iron from a mixture of sulfur. Comprehension. Determine which separation technique can be used to separate the following mixtures: curry water, sugar water, iron and sand, oil and water, alcohol and water, ink and blood. Congratulations, did you get them all correct? So the technique used to separate curry from water would be filtration, and to separate oil from water would be decantation. Simple distillation would be used to separate sugar from water. Chromatography would be used to separate the pigments out of ink. Evaporation would be used to separate sugar from water. Centrifugation would be used to separate the components of the blood. And the magnetic separation will be used to separate iron from sand. Determine the category that each mixture falls under. So here you would need to determine if the mixture is homogeneous, which means uniform throughout, or heterogeneous, which means that it's lacking uniformity. Yay! You got them all right. I am so proud of you. So soda, blood, juice, and air will be categorized as homogeneous, while peas and rice and dirt in water will be both heterogeneous. Good job. Give an example of a solution, colloid, and a suspension. Then explain the basis of using each separation technique given below. Examples of solutions would include soda, salty water, vinegar, air, and alcohol. Examples of colloids would include milk, fog, jelly, and mayonnaise. Examples of suspension would include muddy water, flowing water, orange juice with pulp, paint, and chalk dust in water. Decantation is used to separate mixtures that have different densities. Filtration is used to separate solids from liquids or gases, while simple distillation is used to separate and purify a liquid from a mixture when the components have significantly different boiling points, typically at least 25 degrees Celsius difference. Comprehension. Given the following information, determine the component that is a solvent and the component that is a solute, given that brass is made up of 90% copper and 10% zinc, and 10 karat gold is made up of 41.7% gold and 58.3% copper. Awesome sauce! So the solvent is in the greater amount while the solute is in the lesser amount. Therefore, for brass, the solvent will be copper and the solute would be zinc, while for 10 karat gold, the solvent would be copper and the solute would be gold. Comprehension. Monica was given a mixture of water, salt, and iron filings. She was asked to use her knowledge to separate the water, salt, and iron filings from each other. Answer the following questions below. Questions. What type of mixture was Monica given? And what separation technique may be used to separate iron filings from the mixture? And finally, what separation technique may be used to separate the water from the mixture? Congratulations, I knew you could answer these questions. The mixture that Monica was given was a heterogeneous mixture. To separate the iron filings from the mixture, one could use filtration or magnetic separation. And finally, the separation technique that may be used to separate the water from the mixture may be simple distillation. Great job, guys and gals. I am so proud of you. Thank you for being a part of part 4 of Investigating Matter. See you around for part 5. That will be the last part, and that means you would have completed the series on Investigating Matter. Bye!